This is my approach to triangle questions. I use a 5-stage approach. I first ask, is it an equilateral triangle? If it is, I can use the fact that all the angles are the same, namely 60 degrees, because 180 divided by 3, and if I know one side, say that's 7 centimeters, then every other side must be 7 centimeters. Secondly, I ask, is it an isosceles triangle? If I just know one angle of an isosceles triangle, suppose I know that this is 70 degrees, then I know that must be 70 degrees as well, and that must be whatever 180 minus 70 is. Because of the symmetry, I also know that these two sides are the same. The third thing I look for, is it a similar triangles question? Can also be referred to as an enlargement question. You may also have a situation where, for example, you have parallel lines, and if you just draw two lines like that, you've actually got two similar triangles. I'll draw the red one, that's the red one there, and then you also have a green triangle. They are actually similar triangles. There are some other situations as well. Let's stop there. It's going to be times k. Well, this is what a lot of people use. They say it has a linear scale factor. And by the way, what if you're doing area? Make sure you use times k squared, and if you're doing volume, times k cubed. Anyway, then the fourth thing I look for is it a right angle triangle? If it is, then I know that I can use Pythagoras, which is a squared plus b squared equals c squared, and I can also use SOHCAHTOA. Finally, is it any other triangle? Well, that's easy because it is. So if there's none of those four, it must be some other triangle, in which case you're probably going to use sine rule or cosine rule. Why do I teach it like this, or encourage people to study it like this, or do it like this? The reason is, if you use this process, it kind of picks up any question. And there's some questions where more than one thing applies. So you might have a question where it's similar triangles and they're right angled. In that case, it's much better to use your similar triangles knowledge first, because it may save a lot of time. Similarly, let's just briefly talk about sine rule and cosine rule. Sine rule and cosine rule can be used for any triangle. They really can. I often use sine rule as a short to save time when I'm doing right angle triangle questions. Anyway, if you dive straight in using sine rule or cosine rule, you may have missed something really obvious. I've seen people use cosine rule when it's an isosceles triangle, which means that something that should probably take 5 seconds, and most people can do in their head, might take 4 to 5 minutes. I said, sorry, 4 or 5 minutes. Big time saving, which is why I encourage us to do it in this order: 1 equilateral, 2 isosceles, 3 similar, 4 right angled, 5 any other. By the way, if it isn't equilateral, for example, let's go on to another color, you might end up using other rules. For example, the area rules are half base times height, or 1/2 AB sin C. So you may end up having to use that half AB sine C for an equilateral triangle question. Just a related note, which might be an issue depending on how you're thinking about what I'm saying. Finally, how do I approach questions where there is more than one triangle that you can see? What I do is, suppose this question is asked for x. I just immediately go, can I find x? Because maybe it looks awkward, but it's quite easy. No, I can't see a way of getting x straight away. So I then wish list, and I go, well, what would I like to know to find out what x is? Well, I'd quite like to know that thing there. If I could find out that line, I could then use Pythagoras. So that'd be great. So I know that some people at this point have been going, yeah, but what's the point in that? Because we don't know what it is. And I'm like, well, if it is possible, there must be some way to do it. And I find this is a good way of kind of puzzling it out. So let's just start. I'll very quickly go over that again. I want to find out what x is. Can I find out straight away? No. If I could just find something out, what would be useful? Well, this line here would be useful. Okay. How could I find that out? So then we look over here and go, well, there's another triangle. Could I use this other triangle? Well, that triangle, let's use our standard method. Is it equilateral? No. Is it isosceles? No. Is it similar triangles? No. Is it right angled? No. Okay, so it's one of the others. So it must be sine rule or cosine rule. And in fact, if you work it through, you could use sine rule to find out what this is. So it turns out that you'd use sine rule using 7 over sine 35. I've gone quite fast here, by the way, equals what? Let's call this y. Y divided by sine 80. I'm not going to do all this maths, but if you did, you could then find out what y is, and then that would enable you to find out what x is using Pythagoras.